heap problems from LeetCode list, as it is our heap day of LeetCode gym. So let's do that. I'll navigate to the heap. I'll try to do a problem. Designing Twitter. It's kind of a hard question. I've come across this a lot of time, but didn't muster enough strength to do that. How about let's see single-threaded CPU. How many times it has been asked? So if it has been asked a lot of times, then we can probably do that. Not a lot. So seat reservation manager. Let's see what it is about. Okay, it's been asked by Dropbox. Reorganize string. Okay, this question looks good. So let's try to solve this question. Okay. Given a string S, rearrange the characters of S so that any two adjacent characters are not the same. Got it. Okay. So return any possible rearrangements of S, return null if not possible. Got it. Got it. So how should we go about this? Okay, every possible word, right? Every possible word, whatever it is, what we need to do is, okay, we need to basically pop that thing, right? Pop. Okay. So how can we do that? So what I'm thinking is, should we use a min heap or max heap for that matter of fact? I guess we should be using max heap first, and but if we are using max heap, let's say, and we get a count is 2, what I'm thinking is I'll store every alphabet with their frequency count, so a would be 2 and b would be 1. So a will come one time, it will be pulled from the heap, then again added back to the heap, and then probably b will come, and then a would come, until we have to do this until the heap becomes empty. So how about this case where we are not able to rearrange them? A, what we have to do is, okay, so for rearranging this, we take a equals to 3 and b is equals to 1. Then what happens is, when we take one a out, but yeah, we take one a out and still a is at the top of the element, so that basically defies the purpose of this. What should we do? What I'm thinking is, why don't I take out two elements at the same time, so that I can make sure that I can add them to the list, or will that be a overkill? So for every yeah, if there were two B's, then it would have been possible in this case. A, suppose triple A is there and double B's are there, then after polling, this A will add A, right? And then uh, add A back to the heap, so B will be at the top, so we'll add B, then we'll be polling B, and then A will be at the top, so A will be added, then B, and then A. So things like that. So if we can do that, then that would be great. So I'll use min heap for, sorry, max heap for this one. Yep. um, so let's try to implement the max heap. I sorry guys, I have an interview today, so that's why I'm in bit hurry, so I can make my breakfast and stuff like that. So class pq will have, and it will have a constructor which takes in a callback, uh, a compare function, which this dot compare will take a and b and will pass that a and b to this compare, and if it is greater than 0, then a is greater than b. If so whenever it is positive or 1, like if it is greater than 0, if greater than 0, then value of a is greater than b. If less than 0, the value of b is greater than a. But what we are looking for is, we are going to store the alphabet and the frequency, right? So a of 1 would be pointing at that, and a of b would be pointing at that. And as we are going to do it, yeah, make this function basically, yeah, we are going to make this function max heap, right? Yeah. So what was the next thing? And we have to define this dot heap is equal to an empty array. Okay, so once we have done with this, what we have to do is, we have to actually add, right? Add elements, add value to this guy. So this dot heap dot push, let's call it val, as it is a standard term used in LeetCode. Once we add the val, then for if this dot heap dot length is greater than 1, then what we have to do is this dot bubble up, we need to check for the bubble up, and this dot heap dot length minus 1, we have to do that. Okay, so that would be it. And next we'll code up bubble up. It has the index associated with it. So what we do is, yeah, we have to find parent index, right? So parent index is equal to, what we do is math dot floor, whatever index is there, minus 1 by 2. Why we are doing minus 1? Just in case if let's say if the length of the array was 3, so 3 minus 1, whenever we are sending from line 19, we want to send the last index, right? So 2 would come. So basically 2's parent should be at 0th index, right? But if we don't minus this 1, what will happen is 2 divided by 2 would be 1, right? So that it would be pointing at a different and like not its parent index. So that's why we minus it by 1. So index minus or 2 minus 1 by 2 is 0. So that's why we are doing that. Okay, hopefully that edge case makes that clear. Okay, once we are done with this, what we'll do is yeah, if we have to do the compare, right? This this dot compare, we found out the parent, right? This dot heap of 1, this dot heap of parent index of 1 comma this dot heap of index that we want to bubble up of 1. Okay, so let's see what yeah, once we do this, if the we are if the parent index is greater than or less than, depending on what the compare function is, we want to actually swap them, right? Then this dot swap parent index and index with each other, right? That's what we want to do. So once we swap them both, we also want to make sure that we call this dot bubble up, this dot bubble up on the parent index. And let's say if index is less than 0, less than equal to 0, then there is nothing to be done, right? So we will return from here so that it does not go out of bound. That's why that edge case is there, like that. Okay, so once we are done with this, then we need to also do poll. Poll means get the max or min element. Let me get max or min element. Okay, once, so what we have to do here is this dot swap. Basically, yeah, we have to get the first element, right? So yeah, let's swap them both. So when we are swapping, this dot heap dot length minus 1 and the 0th index we have to swap, and let element, or let's call it item to be polled, is equal to this dot heap dot pop. So the last, so the top of the element, which is 0, has to be retrieved, right? So by swapping the last and the first element, we are making sure that our first element goes to the last index, and then we can simply pop it out, and then basically once we pop it out, we have to heapify the array again. So this dot bubble down, because the swapping that has happened, So a number, a unknown value is at the top of the array, and we don't know if it is a max or min. So to balance it out, we have to again search its rightful place in the array. So what we do is we send bubble down, which is a heapify function, um, yeah, and that to balance the array out, and then we'll return item to be polled. Okay, so return item to be polled. Once that is done, what we can do is polling is done, right? Then what was there, what else was there? Polling is done. Then yeah, bubble down we have to do, right? Bubble down, and it takes an index value. So bubble down is interesting. We have to, so from top we are going down, right? So imagine it as a tree. We have to find the left child, or left index is equal to 2 into the index that has been given to us plus 1 is the formula to find the value of the left index, and right index is equals to 2 into index plus 2. Yeah, that is that. And let what else are we forgetting? I don't think so we are forgetting anything. So yeah, what we have to do is, or let's call it, let parent index is equal to index, let's call that. Okay, because we are going to compare it, right? So if left index is less than or equal to this dot size minus 1, or if it is less than, let's do less than the size, and what we have to do is this dot compare, we have to send this dot heap of our parent index of 1. I guess we don't have to specify of 1 here. We just need the index, and our compare function will take care of the rest. Isn't that right? Yeah, that is right. Okay, so once we do that, what I have to do is this dot heap of left index. Okay, once yeah, if our parent index is min or max, based on that we'll just update left index with parent index. Okay, oh sorry, my bad. Parent index is equal to left index, and we have to also check it with if it is min max, then the right child. Sorry, my bad. I was just looking at the left index, how the left index is written, right? And this dot size, and this dot compare, this dot heap parent index, comma, this dot heap right index. So yeah, once that is done, then we can update parent index is equal to right index. So yeah, once that is done, we have to check if parent index, if it is not equal to the original index, that means the value of the child element is um, is can be replaced with the parent index value, because the parent index is not satisfying the min or max heap condition. So yeah, we have to make sure that parent find its original spot, and we have to either shift left index item to the first position or right index, depending on what we find um, in this comparison. So yeah, this dot swap, we have to swap parent index and the index that was given to us, and once we swap this, then we have to call this bubble down, bubble, yeah, bubble down parent index, yeah, parent index, because our parent would be there. And yeah, that should take care of this. And we haven't defined swap functionality, I and j, let's call it I and j. And then this dot heap of I, this dot heap of j equals to this dot heap of j, and this dot heap of I. So this will basically swap them up. And also the size, we didn't specify the size. This dot return this dot heap dot length, right? That's what we have to do here. And that is it. And we don't have to actually peek at the top, or do we have to peek? Yeah, like let's also define a peek functionality. Yep, let's define that as well. Peek. Yeah, once so if this dot size, okay, if not this dot size, then return, else return this dot heap of 0, whatever is there at 0th index, we want to see that, right? Okay, so that will give our peak, that will give our swap. I don't think so I've missed anything as of now, like any function, any supporting function that I might have missed. So I don't think so. Okay, everything looks good. All we have to do is now focus on the problem. Let's minimize this. Okay, so the problem was like we have to basically create arrange all the string in the what do you call it, in alternate fashion. So for doing that, what I need to do is I need to actually create a hash map and get all the frequencies for the characters that are in the s, okay, because they might be repeating. Yeah, I want to do that. And once I got the, so I can either use an array for that, 26 character length array, uh, 26 length array, or a map. So I'll basically use a map, that would be easier and would not create much mess. Map is equal to new map. Okay, what I'll do is for let ch of s, okay, a map dot set ch, and we have to set ch if map dot get ch, then +1, or just add 1. So this shorthand will help us to populate the map. And then what we have to do is basically then add all of that. So now at this stage we want our max heap, right? Max heap is equal to new pq, and we have to pass the function, right? Compare function. So the compare function will look like a and b, will pass that. And we have to make sure that it's a max heap, right? So b of 1 minus a of 1 should be compared, because that's where we are storing the frequency of that particular element. Yeah, that's what we have to do. So this is the compare function that we are going to send. This is our max heap, and now what we have to do is let character of map dot key. I'm not sure what it is, but I guess it's keys. If I turn on auto, I might know it. Let's turn on auto and let's see, so that we don't waste our time. Key, yeah, keys, it's a method. So we have the characters, and then what we do is max heap dot add. Let's destructure it. Basically, let ch or let's call it char, and frequency is equal to or let's do this, add ch would be the key, right? Ch would be the key, and map dot get ch what gets us its frequency. So that will be added. Why don't we check how our max heap is looking like? Max heap dot heap. So just for comparison's sake, I just for making sure that we are doing the right thing. So yeah, a is 2 and b is 1. If you see the first example, a is 2 and b is 1, and a is at the top of the heap. So actually what we have coded is right so far, and what we have to do next is that we have to, until my max heap is empty, I have to basically keep adding the value. So we have to at last we have to send a string, right? Result, let's call it result, which will be initially empty. Okay, and basically at the end we have to return the result. Okay, so yeah, and we have to do like run this loop until max heap dot size is not 0. So this will make sure that it's running until it's been done. What the hell? What the hell is wrong with my camera? Seriously? I guess I have to reinvest in. Okay, now it's fine. I didn't know what went wrong there. So okay, we are here, and then max heap dot size, we have that, and okay, so I guess what I have to do is, if my results last element and my max heaps peak element, if it is equal, then I'll be returning false. I'll be returning empty string. That's what I'm going to do. Result dot length, let result length, let's get the result length, and if result length -1 equals to max heap dot peak what are we peaking in the, like, are we sending 0 or how is it like? Okay, max heap, let's take let ch comma frequency, let's take that from max. Okay, let's pull it out, either ways we have to do that, right? And let's pull this out, and whatever, if ch is equal to the last element that we have added, then we'll simply return an empty string, or else if it is not equal, then what we have to do is add result plus equals to that character, we'll add it, and max heap dot add that ch, we have to add it again, and frequency minus 1. Okay, and before adding, let's make sure frequency, let's minus equals to 1, and if frequency is equal to 0, then if it is not equal to 0, then what we'll do is we'll add this guy here. Okay, that's what we'll do, otherwise we won't add it back to the heap. And once we have decremented the frequency, I guess we don't need to do it here again. So yeah, let's see if this works. What is the error? Oh, result, sorry, result, sorry, I mistakenly typed res. But yeah, once we are done with that, let's do it. Okay, yeah, it's passing, but I considered the edge case in this case. Okay, if s dot length, so we can make sure that we are not doing, if s dot length is equal to 1, then return s. If it is less than equal to 1, okay, then we can probably return s, and but later we can simply do this. Let's try to add another test case before I submit this. Just 2 A's. I'm just trying to gauge how it's behaving. Okay, that is working fine, so fingers crossed. Let's submit this. Okay, so 41 test cases passed out of 70, but BAA expected was ABABA. Okay, so where did we went wrong? So A is 3. Let's add this unit test case. Yeah, and let's console.log the result and max heap at every stage. So my max heap is this guy, b is equal to 2. Oh, how come my max heap is b is equal to 2? It should have been a is equal to 3, right? A is 3. Okay, is this a problem with my heap? Oh, okay, sorry. I shouldn't have done this here. Okay, yeah, now it's passing. See, my a certain logic in my code wasn't right. Okay, so 48, this is not passing now. So let's see what it is exactly. VVVLO, triple VLO. So V is equal to 3. So okay, V is equal to 3. V is equal to 3 and LO is there, right? And so V becomes 2 and L is 1, so V again comes up. Okay, got it. So do we need to pop 2 elements from the pole? That's what we have to do. Let um, okay, ch2 and frequency 2 is equal to, but how will know? I have to check max heap dot um, dot size. If max dot heap dot size is greater than or equal to 2, or or let's say if it still have anything left in it, then what we'll do is max heap dot poll. Yeah, we will poll again, or else can we do this? Yeah, okay, so ch2, if result dot res len minus, okay, yeah, oh, sorry, I guess I have to also check it for result of, so these guys won't be equal to each other, right? Yeah, so I can simply add result plus equals to ch2 as well, and frequency result plus equals to, if ch2 is there, then ch2, or else if and frequency 2 equals to, if frequency 2 is there, then frequency 2 minus 1 would be assigned to it, and we also have to add, if frequency 2 is not equal to 0, then max heap dot add. I guess I might be going to get wrong with whatever I have implemented, um, this I think so, because it doesn't look right to me, like there are so many ifs and buts. Max number 1 is not iterable. Okay, I guess I might be going wrong here. It would be a good idea to see the solution for this. O of n? Seriously? So count letter appearance and store it in hash. Find the letter with the largest occurrence. Put the letter into even index number 0 to 4 character. Put the rest into the array. Okay. Put the rest into the array. Okay. What is the editorial has to say? Counting and priority queue. So I did that right. So this is what we did. A. Next element in sequence will be second element of priority queue, because last element of sequence matches first element of priority queue. First element of priority queue A, second element of priority queue B is equal to 3. And in the next element in sequence will be the second so how are they doing that? So looks like yeah, so they are counting the characters, then putting everything into the character with character and the character count and the I. Then while the priority queue is not empty, that's what they are doing, they popped first character, and if result is not empty, or result first of 1 is not equal to result back, yeah, they are looking at the first element, like the current character, and the last element. If they are not equal, then they are adding that first character, then again pushing that first pq dot first, whatever first is there, they are pushing it back again. Okay, so else if pq is empty, then return auto. What is auto? Second pq top, second. Okay, they are taking out the second, and okay, what they, I get it, what they are doing here. So they are basically doing the same thing what we did here. So yeah, let's get rid of this. Let's get rid of this also. Let's get rid of this also. The logic of ours was right, but in this case, what they are doing is max dot pool. Let's call it current char current. Let's call it yeah, let's call it first max first max, and what we'll do is if result dot length, if result dot length, if not result dot length, or first, like the first max of of 0, yeah, is not equal to result of rest len minus 1, then what we have to do is we have to add the character back, add the character to the result, and what we have to do is else what we have to do is we have to check if PQ is empty, the max heap dot size. If the size is empty, then return the null, because we were not able to find. Okay, this is interesting. So let second max is equal to max heap dot poll. Okay, max heap dot poll, and then what we have to do is we have to straight away add that result plus equals to second max of 0. Okay, and if then I guess what we have to do is if, yeah, we can totally do this. If first max of 1, if we do minus of it, and if it is not equal to 0, then we can simply add the first max back. And similarly, in the case of if minus second max of frequency count, like 1, if it is not equal to 0, then we can add max heap dot add second max, and also we can then add because did we poll it already? Yeah, we polled it. So max heap dot add first max, and once we do this, okay, so yeah, once we do this, we can basically achieve the result. Oh, ch, it shouldn't be ch, it should be first max of 0. So we polled this, right? Second maxi poll, then equal to 0, then return. Okay, now it worked. So let's submit it. Hopefully this works. Cool. The time complexity is really bad. Like for every ad, it is log n, and for every every pole it is also log n. So I guess it's the time complexity is n log n for this one, and the space complexity is basically n would be where n um, would be distinct elements and their frequency count. But yeah, the space complexity would be of 1, but we are as we are storing it in the heap, yeah, it won't ever exceed 26. So can we say of 1 for that matter of fact, because it's not ever going to exceed the 26 mark. So of 1 will say of k, the counter used to count the number of occurrences will incur a space complexity. Similarly, the maximum size of the priority queue, given that k is 26, in this problem one could argue that the space complexity is of 1. Yeah, true. Cool. So yeah, it's 8:40 guys, it's almost time. I'm sorry I was not able to cover 2 questions, but this took good enough time for us, and it's pretty good question to be asked in an interview, because and really important. So let's mark this boy as done, and let's add it. Whoa, what is this button not working? Yeah, I guess it's not working, but anyways, let me write a note. I had to look up the solution from the editorial. There is one more implementation which do not use heap. Please take a look into it. And is there anything else? Is there anything else that we want to do? Okay. We were actually closer to solving this problem, but did not see the edge case.